All right, Math 8 students, what we are going to do here is I said that we would do this your turn for warm-up in class on Thursday, but maybe you're absent or maybe you want to see the explanation again, so I'm going to go ahead and just make a quick little video here explaining how to solve this type of problem. This is lesson 3.3, and I am using a different application for recording, so it's going to look a little bit different than the previous videos. This is kind of the trial run. We'll see how it goes. So this is lesson 3.3. So let's go ahead and read this your turn scenario. The equation y equals 375x represents the relationship between x, the time that a plane has flew in hours, and y, the distance the plane flies in miles for plane A. So let's go ahead and make plane A red, and it is an equation here. And the table represents the relationship for plane B. Let's go ahead and we're going to make plane B blue. Find the slope of the graph for each plane and the plane's rate of speed. Determine which plane is flying at a faster rate of speed. So this is plane B. So what I'm going to do is I'm going to make a table for plane A, but that means I need to understand what my unit rate is and what my constant of proportionality is. Those are the same thing. So we're going to go ahead and take a look at this equation where y equals 375x. Now if I remember what that equation was, that is y equals k times x, where k is my constant of proportionality. So this is telling me that k equals 375, and anytime that I have a number by itself, that is telling me it's 375 over 1, so 375 miles per hour. So I already know what my constant of proportionality is, which is also happens to be what my unit rate is, because it is my value for 1 hour. It's 375 miles per 1 hour. So the constant of proportionality for plane A is 375. I could also, maybe it's not that simple, so we could also have made a table for plane A where we have our hours on top and our miles on bottom. This is our x and this is our y. And we know that in 1 hour it's traveled 375 miles. In 2 it's traveled 750. In 3 it's traveled 1125. I think my math is right there. And in 4 it's traveled 1,500 miles. So, and then we could also just compare our points here. 1 hour 425, 1 hour 375. Which is what it wants us to do. It wants us to determine which plane is flying at a faster rate of speed. Well, we have our unit rates already, right? So we determined that this is our unit rate for plane A. Plane A's unit rate is 375 miles per hour. And plane B, we can look at this table here, and it has our comparison of miles per hour. So our 1 unit, what is our distance per 1 unit? That unit rate would be 425 miles per hour. So you can use the equation and determine what that means based on, what we've got going on here with the equation. Maybe it's not this simple, it's not this straightforward, so you could make this table, right? And then you can compare the two tables. So you've got your B unit rate, your plane A unit rate, and we can see based on this which one is bigger, or which one is faster. The plane that's traveling faster is B, because 425 is greater than 375. Let's make sure we got everything this question is asking. So the table represents the relationship for plane B. Find the slope of the graph for each plane and the plane's rate of speed. Determine which plane is flying at a faster rate of speed. Okay, so what did we learn today about slope and unit rate? And that would be that in proportional relationships, K equals M, being slope, right? Because M is our change in Y. Remember this little triangle symbol here represents change in Y over change in X. Our change in Y for plane A is 375 over 1, And our slope for plane B is 425 over 1 also. So we've compared those slopes. With this information, we could actually draw graphs if we wanted to. We're not going to do that, but you could create a graph and you would travel. This is telling you that this is your rise. So this is your upward movement. This is your run. This is your rise. This is your run. If we were to graph these, I guess I'll go ahead and just talk about that, because you can stop anytime you understand the concept. This would look like plane A has a slower rate of change, so its slope would be a little bit shallower. It's not moving as fast, so its slope would look a little bit shallower than plane B, who's moving a little bit faster. So if we were to graph these, and this is just an approximation of what the graph would look like, but since plane A is traveling faster, it is going to move at a steeper slope, right? Because it's going up 425 over 1, up 425 over 1, whereas plane A is going up 375 over 1, up 375 over 1. So it's not going up as fast. Okay, so that was kind of the long version, the very thorough explanation of how to solve this, but you could have done it in any number of ways. Again, we want to work smarter, not harder, so if you can look at the equation and look at the table and have that answer in less than 30 seconds, awesome, do that. I just wanted to show you all the ways that you can solve this because everybody finds different ways to be easier. Right? So, hopefully this format worked okay. We'll see how this transfers. If so, maybe I'll use this application some other time. If you want to use an application that's fun to kind of explain and draw and record, you can use on your iPad. This application is called Explain Everything. It is not free, but it is neat.